What's going on YouTube? Coach Carr here bringing you another video. Now this one is on page 8 and we're going over the different types of regular polygons and how to find their interior angles. So I hope you enjoy. The success criteria for this one is I will be successful when I know how to find the interior angles of a regular polygon. Okay, so what I have done is on page 8, this is the very top of it. I want you to write this in. So for a regular polygon is a shape where interior angles are congruent and all sides are congruent. Now, the next vocab word is convex. It's a figure where all interior angles are less than 180. So I have a picture on there that can be an example. If you notice in the one that says a convex polygon, every single one of those interior angles are going to be less than 180 degrees. So 180 degrees would be like a straight line. The next vocab word, concave. Now that is a figure with at least one angle greater than 180 degrees. And that'll be wherever it caves in, hence concave. So in the picture, if you notice, most of them are less than 180, but that one in the middle that kind of dips down at the top of the concave polygon, that would be greater than 180 degrees. So really the only shape that can't be concave is a triangle, because in a triangle, all the angles inside have to add up to 180 degrees. And then the last thing to know stuff about the interior angles. So the interior angles, so the angles for each individual vertice. If I wanted to find each angle, what I would do is 180 times n minus 2, where n is the amount of sides, divided by n. So that would give me each individual angle. Now, if I want to know the how many degrees the inside would be in total, then I would just do 180 times n minus 2, where n is the amount of sides. So for instance, like let's say you said a triangle. A triangle has 3 sides. If I did 180 and then in parentheses 3 minus 2, it would be 180 minus 1. And as we know, the inside of a triangle does in fact have to equal 180 degrees. Okay, so on that same page, now we're going to look at all the different types of gon. So a hexagon, octagon, 20gon, and so on and so forth. So what they want us to do is find the interior angle measure. So from the notes that you should have just taken a second ago, to find that you would do 180 times n minus 2 all over n. So if we did this, a hexagon has 6 sides. So I would have 180 times 6 minus 2 over 6. 180 times 6 minus 2. So 6 minus 2 is 4. All still over 6. 180 times 4 is 720. So 720 over 6, which equals 120 degrees. So that means each angle in here is 120 degrees. Because if it's a regular polygon, in this case a hexagon, then all angles and all sides have to be congruent. So the next one, this kind of gon has 12 sides. So if it has 12 sides, if we went ahead and did this, 180 times 12 minus 2 all over 12. So I'd still have the 180. 12 minus 2 is 10 all over 12. When these multiply together, you get 1800, still divided by 12, which equals 150 degrees. So each angle inside here would be 150 degrees. The next one, if it was a 20gon, 180 times 20 minus 2 over 20. So 180 times 18 over 20. 180 times 18 is 3,240 all over 20. And that equals 162 degrees. The next one is saying predict what a 100gon would look like. So if you notice, each shape is gradually looking more and more like a circle. So this one would probably look very similar to a traditional circle. So when we do it, you would have 180 times 100 minus 2. 180 times 98 all over 100. So I forgot to put this over 100, but it was over 100. When I multiply 180 times 98, I get 17,640 all over 100. And that would get me 176.4 degrees. So if I had like a bunch of dots in here, they would all equal about 176.4 degrees. Okay, so last bit of this page is answering the questions on the bottom. Now, the first one says, what do you notice is happening to the interior angle measure as the number of sides increases in each shape? Well, if you notice, the degree kept going up and up as the shape got more sides. Now, it all got very close to 180 degrees, but it's never going to be more than that in any of these regular type of polygons. So what I'm going to write is as sides increase, it gets closer to 180. So it got closer to 180 degrees, but it will never be more. So that would be my answer for that question in particular. The next problem, what do you notice about the number of congruent triangles that can be drawn into the polygons? Now, I never actually drew any triangles in here, but I'll do it to the hexagon so you can see what exactly they are talking about. So let's say I drew some triangles in there. So if I wanted to make a bunch of triangles that were all congruent to each other, I would want to make a bunch of lines that are going to the middle. So because the hexagon has an even amount of angles, I can just go across with them. But as long as you draw them going through the middle, you're pretty good. So for the most part, we're pretending like I drew this perfectly and that they all are even. Even with a ruler, it still doesn't look perfect when I did it. But the amount of triangles I have, 1, 2, 3, 4, 5, 6. Now, if you notice, that's the same amount of sides. So the number of triangles is congruent to the amount of sides. So the number of triangles is going to be congruent to the amount of sides in any kind of regular polygon. That's the end of another video. Thank you again for watching. Make sure to like, subscribe, and there will be the exit slip will be kind of the same idea where you have to have a certain amount of points on questions that are on regular polygons. So you're probably going to want to watch the next video to be even more successful on those.